Hello everyone. So this is part 2 of solving the specimen paper 2. So let's get right into it. So question 13. Find the number of sides of regular polygon with interior angle 162. So the way to do this is to firstly calculate the total number of angles, the total value of all of the angles in this polygon. And there's a formula for this, and it's in my formula booklet, which is 180 n minus 2. This is the total value of all the angles in a polygon with n sides. But now to find the value of one interior angle, you divide it by the number of sides in the polygon. So divide that by n. And then we set this equal to 162. So if we move over the n, multiply both sides by n, we get this. And then 180n minus 360 equals 162n. And so if we get 18n is equal to 360. Therefore, n is equal to 20. And that's it. That's the answer. After we just solve for n once we get this this very important formula. Okay, now the range, mode, medium, and mean of 5 positive integers are all equal to 10. All equal to 10. Find one possible set. Okay, so we just have to find one. There could be many, and we just asked to find one. So the first thing is, if you have 5 integers, and the median is 10, then the middle number must be 10. So that's it. That's the middle number must be 10, since they're all integers. And now we know that if the mean is all equal to 10, the sum of these 5 numbers must be equal to 50. So that when you divide it by 5 to find the mean, it's 10. Okay, and the mode is 10. So, and the range is also 10. So if this number is a, this is a plus 10. So one possible set I'm already thinking of right here is, it won't take much time, but if you do some little experimentation, you'll see that if you want the mode to be 10, you could have these 3 numbers in the middle as 10. And then that gives you a sum of 30. And then if you have this as 5 and this as 15, now you can see that the range is also 10. 15 minus 5 is 10. And then the sum of these 5 numbers is also 50. So the mean is 10. The mode, most common number, is also 10. And if you see that that's all the conditions are satisfied here. So that's one answer we have. And that's all you need for the 4 marks here. Okay. Now question 15. Describe fully the single transformation that maps this triangle T onto triangle A. Okay, so immediately I can already see it's a rotation. And you can see that it's a rotation in this direction, which is counterclockwise. It's clockwise. It's moving in a clockwise direction from T to A. It initially starts like this, and then once you rotate it, it becomes like this. And it's a 90-degree rotation. It only moves 90 degrees. So if we write that here, rotation. Writing rotation is just 1 mark already. And then 90 degrees clockwise. That's another mark. Now we have to find the center of rotation. So ideally in an exam, you would have tracing paper, and you would trace the shapes and then calculate the point of rotation. But here I'm going to show you one way of doing it in case you don't have tracing paper, or if you want to check your answer. So the way you do this is you connect the 2 corresponding vertices. So let's first start with the top one. And then you draw the perpendicular bisector of this line. And it looks like the perpendicular bisector. The perpendicular bisector will look something like this. And now if you connect the 2 points for any next pair, let's say we connect this corner to the corresponding one and draw the perpendicular bisector, it will look something like this. And now we can already see we have an intersection point here of the two perpendicular bisectors, which tells us that the center of rotation is 4, 3. 4, 3. But if you want to be, if you just want to be extra sure, to verify your answer, you can do it for the third point, the third corner. You connect them up, and then you draw, and you can see the perpendicular bisector is exactly the same for this line too. It's just this right here. And so yeah, this is a method that's not often taught in. This is not often taught because students are often taught to do it with tracing paper. But I just thought this is a nice and creative way to do it as well, without tracing paper, or if you just want to check. So finally we can write center of rotation 4, 3. Okay, that's that question done. Now we have a cumulative frequency diagram which measures the height of 400 different plants. Use the diagram to find an estimate for the median. So to find an estimate for the median, all we do is we see the sample size here, which is 400 different plants, and then we divide that by 2. So 200, that's the median, the middle value, and then we draw a straight line from 200, dotted line going across, and wherever it meets the graph, we then draw a line going downward like this. And you can see that the median is 30 centimeters. So we can write that down, 30. Now we want to find the interquartile range. So the interquartile range is equal to the upper quartile minus the lower quartile. And the upper quartile is the total sample divided by 4 multiplied by 3. So 3n over 4 minus the lower quartile is n over 4 minus the value at the n over 4th position. So, and this is, by the way, this formula is also in my formula booklet. So the position of the upper quartile would be 3 by 400 over 4. And we just simplify this. This gives us 300. So what we do to find the upper quartile of this data set, so we draw a line from 300 across. So you can see that it meets there. And then here, this is 37 centimeters. So the upper quartile is 37 centimeters. And the lower quartile now is n over 4. So that's 400 divided by 4, which is at the 100th value. So we draw a line from 100. This is 100. This is 300. We draw the line going down. And this is 17. So therefore the upper quartile is 37 and the lower quartile is 17. Hence the interquartile range is 20. So that's our answer for that. Now we want to find an estimate for the 80th percentile. So the way we do this is we just multiply 80% by the dataset 400 number of plants. So 80% is 0.8 multiplied by 400. and that is equal to 320. So now the same process we've done, we draw a line from 320 and down to where it meets the graph. And you can see it meets at 39 centimeters. So therefore the 80th percentile is 39 centimeters. Now the number of plants with a height greater than 60. So now we did the reverse. We draw a line from 60 and then we extend it back. So now it meets the y-axis at this value of, it appears like it's around 364. So 364. Hence at 364, the plant is 60 centimeters. So if you want to find the plants greater than 60 centimeters, we find the number of plants greater than 364. So basically this range. So we just do 400 minus 364. And that's equal to 36. So our answer is 36 for that. Okay, now onto histograms. We want to draw a histogram to show this data in the table. And the way we do this is we use the formula frequency density is equal to frequency over class width. So if we draw a new, I would recommend doing this in the exam, draw a new row frequency density. And then use this formula. It's also in my formula booklet. Frequency 120 divided by class width. Class width is basically the upper value of the class minus the lower value. So 20 minus 0, in this case 20. So the frequency density of this right here would be 120 over 6. So 20. Which is why, oh sorry, I skipped ahead right there. The answer is 6 because 120 divided by 20 is 6. So it's 6. The frequency density is 6. Because the frequency is 120, class width is 20. So and 120 divided by 20 is 6. Now that's why on the graph here, it's drawn at this level of 6 from 0 to 20. So we continue this process. Frequency density for the next one is 80 divided by 10. Class width for this one is 10. Because you do upper bound minus lower bound, so 30 minus 20. So that would give us a frequency density of 8. For the next one, 124 divided by 10 again, 12.4. Then for the final one, 76 divided by 40. It helps to know that 76 is equal to 4 by 19. So here 76 divided by 40 is therefore equal to 1.9. So 1.9 right there here. And then all we do now is we complete the histogram with the frequency density. So for the next one in the range 20 to 30, it goes all the way up to 8. So it would look like that. And then 30 to 40 is 12.4. So that would be that. And then for the range 40 to 80, it's 1.9. .9 is around there. And yeah, that's the histogram done. And that's that question done. Okay, now we move on to circles and circle theorems. So we have a cyclic quadrilateral. Instantly, this is another sugar word that you should know. Any cyclic quadrilateral opposite angles sum to 180 degrees. And BD and AC intersect the X. And they've given us these angles here on the diagram. Find angle BDA. So this angle here. Well, if you remember from the circle theorem, I have a full video going through each circle theorem along with some of their proofs. Angles in the same segment are equal. So there are two angles here that subtend the arc AB. We have this angle right here, angle ACB, and angle ADB. They both subtend the same arc. Therefore, angle ADB is equal to angle ACB, which is 34. So angle BDA here is 34. It's the same as this angle here. Angle BCD is this entire angle here. And remember that the opposite angles sum to 180 in a cyclic quadrilateral. So this angle right here, 74, is opposite to this angle here. And therefore, angle BCD is 180 minus 74, which is 106 degrees. And finally, angle ABD. Angle ABD is this right here. And ABD is a triangle. So therefore, angles sum to 180. So angle ABD is 180 minus 74 minus 34, which is equal to 180 minus 108, which is 72 degrees. Hence that is 72. Okay, now in the diagram, triangle ADX is similar to triangle BCX. So this triangle here is similar to this triangle here. BC is 4.5, AD is 9, CX is 3.3. So if we label that on the diagram, BC is 4.5, AD is 9. So this is 4.5 centimeters. This is 9 centimeters. And CX is 3.3 centimeters. Right here, this. Now we're being asked to work out XD. XD is this right here. Okay, so already we can see that the ratio between the similar triangles is 2, because 9 divided by 4.5 is 2. So if we want to put this as a formula, we get that 9 divided by 4.5 is equal to C is equal to dx over cx, which is, so therefore it's equal to dex over 3.3 centimeters, because those two are corresponding sides and the scale factor is 2. So therefore it's xd over 3.3. So 2 is equal to xd over 3.3, and so xd is 6.6 centimeters. So the answer there is 6.6. 6.6. So this is 6.6 centimeters. And you can already see, you can visualize it. If we have this triangle here, right here, 4.5, 3.3, and triangle ADX is basically the same, but just double of all the sides. So here it would be 9 centimeters, and therefore that's the reason this is 6.6. Each side in this triangle is twice as large as each side in that triangle. Okay, now functions. We're given these functions, find f of -3. So all we do is substitute in -3 into this right here, fx. So this is 3. Be careful of the two negatives. They become a positive. 3 plus 6, which is 9. So 9 is our answer. Find g f -3. Well, we know that f of -3 here is 9. So basically we're just finding what g9 is. So in this 2x plus 3, we substitute 9. So 2 by 9 plus 3, which is 18 plus 3, which is 21. So our answer for that is 21. Now we have to find f inverse of x. So our process of doing this is, firstly we let y equal to 3 minus 2x. And now we flip the variables, so x equals to 3 minus 2y. The reason we do this is because if we have a function, let's say something like this, whenever we're finding the inverse, what we're basically doing is reflecting in the line y equals to x. And which is why when you reflect it in the line y equals to x, it becomes the x and y coordinates flip around, hence why we're doing it here. But knowledge of this right here is not really needed until you get into higher maths, like additional maths or A-level maths. You'll learn more about y, but I just wanted to, because it makes it easier for you to understand why we're flipping the variables instead of me just telling you that we are. So yeah, but you don't really need to know this for IG. So now what we do when we have this is we want to make y the subject of the equation. Should be familiar with that. So 2y is equal to 3 minus x. Therefore y is equal to 3 minus x over 2. And so our answer is, now that we've got y as a subject, we can just replace it by f inverse of x. So it's equal to 3 minus x over 2. Next, find x when g of x is 7. So we can rewrite this as with an extra pair of brackets, like that. Makes it easier for us to see what's going on. So we can replace g of x by 2x plus 3 up here. And then this is equal to 7. And now if we replace the 2x plus 3 every time there's an x in the function, it becomes 2 by 2x plus 3 plus 3 equals to 7. What we're doing here is we have this right here, and all we do is replace it with this x right here. So g 2x plus 3 is equal to this, and this is equal to 7. And now this is an equation in terms of x which we can solve. First we expand the brackets. And so 4x is equal to -2, and so x is equal to -1/2. And that's our answer there. And now the final functions question. Find x when h inverse of x is equal to 5. So when h inverse of x is equal to 5, x is equal to h of 5. That's because when we have the inverse of a function, it's just equal to x. This is a important identity that you should know. The inverse of a function of itself is just x. So therefore, if we do h inverse of h of 5, that would be equal to 5, which is what we have on this side. So therefore, we see x in here must be equal to h of 5. So x is equal to h of 5. And what is h of x? H of x is 2 to the power of x. So we just replace x with a 5 2 to the power 5. So x is equal to 2 to the power 5, which is 32. So x is equal to 32. So yeah, that's the end of part 2 of this series of solving the specimen paper for the 2025 exams. If this was helpful, please stay tuned for the next part 3, where I finish solving the entire paper. See you there.